Have you ever wondered why eclipses occur only on specific dates and not every month? Now there's a question that has both baffled and fascinated humanity for centuries. Eclipses, those elusive and ethereal celestial events, have long been shrouded in mystery and intrigue. Throughout history, they have been viewed with a sense of awe and wonder, often associated with myths, superstitions, and sometimes fear. In ancient times, cultures around the globe attached deep religious and cultural significance to these cosmic occurrences. For some, they were ominous portents, heralding disaster or change, while others saw them as divine spectacles, a testament to the power and grandeur of the gods. But what exactly are eclipses? Essentially, they are phenomena that occur when one celestial body obscures the light from another. There are two main types we're familiar with: the solar and the lunar eclipse. Solar eclipses happen when the moon gets in between the Earth and the sun, casting a shadow on certain parts of our planet. These are the ones where it seems like the sun has been blotted out, creating an eerie twilight in the middle of the day. Then we have lunar eclipses, which are a bit less dramatic but equally fascinating. These occur when the Earth lines up between the sun and the moon, casting a shadow on the moon. This is when we get to see that stunning spectacle of the moon turning a deep blood red. So, while eclipses may seem like a rare and mysterious event, they're actually a natural result of the cosmic ballet that's constantly happening above us. They're a reminder of the complex and beautiful mechanisms that govern our universe. Intriguing, isn't it? Let's delve deeper into the science behind these fascinating celestial events. To understand eclipses, you must first grasp the intricate dance of the Earth, the sun, and the moon. Picture, if you will, the grandeur of the cosmos. In this vast expanse, our Earth, sun, and moon are entwined in an ageless waltz, each swaying to the rhythm of gravitational forces. The Earth, our home, performs a stately revolution around the sun, completing one full circle every 365 days. This journey, this orbit, is not a perfect circle, but an elliptical path that brings us closer to and further from the sun over the course of a year. Now imagine the moon, our constant companion. It too is caught in a dance, but its partner is the Earth. Every 27.3 days, the moon performs a full pirouette around our planet, following its own elliptical path. This is why, from our perspective, the moon appears to change shape throughout the month, waxing and waning from a thin crescent to a full glowing orb. But why don't we see an eclipse each month at the new and full moon? Here's where the dance gets a bit more complicated. You see, the moon's orbit is slightly tilted compared to the Earth's orbit around the sun. This tilt, about 5 degrees, usually keeps the moon either slightly above or below the direct line between the Earth and the sun. It's this tilt that prevents us from having monthly solar and lunar eclipses. Instead, eclipses only occur when the Earth, sun, and moon align perfectly, a moment when the dancers on our cosmic stage find themselves in perfect synchrony, a rare and beautiful moment indeed. So, there you have it, the celestial ballet in a nutshell. The Earth and moon pirouetting around the sun, sometimes aligning just right to create the fascinating phenomenon we call an eclipse. By now you should have a basic understanding of the celestial ballet, but how does this lead to an eclipse? Imagine a day suddenly turning into night. That's a solar eclipse for you. A solar eclipse is a celestial phenomenon that has fascinated humans for ages. It's like a grand cosmic waltz where the sun, the moon, and the Earth align perfectly, and the sky dims as if someone just turned down the brightness. So what's the science behind this captivating spectacle? Let's delve into it. When the moon orbits around the Earth, there are times when it moves between the Earth and the sun. This alignment causes the moon to cast a shadow onto the Earth, and voila, we have a solar eclipse. Now you might be wondering, why doesn't this happen every new moon? Well, the moon's orbit is tilted about 5 degrees relative to Earth's orbit around the sun. So, most of the time, the moon's shadow misses Earth completely. Only when the orbits align just right do we get to experience this cosmic ballet. There are 3 types of solar eclipses, each offering a different spectacle. The first is a total solar eclipse. This occurs when the moon completely covers the sun. From Earth, it appears as if the day has turned into night. The area on Earth where this total eclipse can be seen is called the umbra. It's the darkest part of the moon's shadow. Next, we have the partial solar eclipse. This happens when the moon covers only a part of the sun. So, the sun appears as if a chunk has been bitten off. The area on Earth experiencing this partial eclipse is referred to as the penumbra. It's the lighter, outer part of the moon's shadow. Lastly, we have the annular solar eclipse. This occurs when the moon is farthest from Earth in its orbit, making it appear smaller. So when it moves in front of the sun, it doesn't completely cover it. Instead, it leaves a ring of sunlight around its edge, creating what's known as the ring of fire. The term for this is annularity. Each type of solar eclipse is a sight to behold, a moment of wonder that gives us a glimpse into the immense scale and beauty of our universe. But remember, never look directly at a solar eclipse without proper eye protection. The sun's rays can damage your eyes permanently. So, the next time you find yourself under the shadow of the moon, remember the intricate dance of celestial bodies that makes this event possible. The science behind it is as fascinating as the spectacle itself. A spectacle indeed, but the night show is equally captivating. Let's explore lunar eclipses. A full moon night and suddenly the moon turns blood red. Sounds eerie, right? But it's just a lunar eclipse. Now let's picture this. The sun, earth, and moon are all lined up in space. The earth is sandwiched right in the middle. The sun's light is projecting the earth's shadow onto the moon. This, my friends, is the basic setup for a lunar eclipse. But of course, there's more to the story. Lunar eclipses occur in stages. The first stage is the penumbral eclipse. Imagine the Earth's shadow as two concentric circles. The outer circle, or penumbra, is where the Earth blocks some, but not all, of the sun's light. If you're watching the moon at this stage, you might notice a slight darkening, almost as if the moon is being subtly veiled by a cosmic dimmer switch. Next, we move to the partial eclipse. This is when the moon starts moving into the inner circle of Earth's shadow, known as the umbra. The umbra completely blocks the sun's light, and as the moon moves into this shadow, it starts to look as if a bite has been taken out of it. The moon continues to move into the umbra, and the bite becomes bigger and bigger. Then comes the moment we've been waiting for, the total lunar eclipse. At this point, the entire moon is within the umbra, but wait a minute. Why does the moon turn red? Shouldn't it be completely dark, hidden in the Earth's shadow? Well, this is where the magic of our atmosphere comes into play. You see, even though the Earth is blocking direct sunlight, some light still reaches the moon. This light, however, doesn't take the direct route. It passes through Earth's atmosphere first. And our atmosphere, being the incredible natural lens that it is, bends this light, scattering the shorter blue and green wavelengths and letting the longer red wavelengths through. This refracted red light then illuminates the moon, giving it an ethereal reddish hue, often referred to as a blood moon. And then as the moon moves out of the umbra, the process reverses. The bite starts to shrink, the moon lightens, and we move back through a partial eclipse and then the penumbral stage until the moon is back to its full bright self. So the next time you see the moon turning a mysterious red, you'll know it's not some cosmic sorcery, but a beautiful dance of celestial bodies and light. A dance that highlights the precision of our universe. A dance that reminds us of our place in this grand cosmic ballet. Now that we know how eclipses occur, let's find out how to view them safely. Watching an eclipse can be a thrilling experience, but safety should always be a priority. It's easy to get caught up in the excitement of such a rare celestial event, but it's just as important to ensure that you're protecting your eyesight. When it comes to solar eclipses, you should never look directly at the sun. Even when it's partially obscured, the sun's rays can still cause serious damage to your eyes. That's why you need to use proper solar filters or eclipse glasses. These aren't your typical sunglasses, mind you. Eclipse glasses are designed specifically to protect your eyes from the intense solar radiation. They block out the harmful ultraviolet and infrared light, allowing you to safely observe the sun. When purchasing eclipse glasses, make sure they meet the global safety standard ISO 12312-2. This guarantees that the glasses have been tested and proven to provide adequate protection against the sun's harmful light. Additionally, if you're using a telescope or binoculars to view the eclipse, make sure they're equipped with a solar filter. A telescope without a filter can amplify the sun's rays and cause even more damage to your eyes. So, always use a filter and make sure it's attached to the front of your telescope, not the eyepiece. On the other hand, lunar eclipses are much more viewer-friendly. You don't need any special equipment to enjoy a lunar eclipse. Unlike a solar eclipse, a lunar eclipse occurs when the Earth blocks the sun's light from reaching the moon. This means you can safely watch a lunar eclipse with the naked eye, binoculars, or even a telescope without any risk to your eyesight. So whether you're planning to watch a solar or lunar eclipse, always remember to prioritize your safety. Eclipses are breathtaking, awe-inspiring events, but they should never come at the cost of your eye health. Remember, never compromise on safety while enjoying these celestial spectacles. Eclipses, though a simple play of shadows, are indeed a marvel of our universe. As we wrap up this cosmic journey, let's take a moment to revisit and summarize the key takeaways from our exploration of the enigmatic phenomenon we call eclipses. We began our journey with an understanding that eclipses, at their core, are nothing more than a celestial dance. The Earth spins on its axis, the moon orbits the Earth, and the Earth orbits the sun. This intricate ballet of celestial bodies, coupled with the perfect alignment of the sun, the Earth, and the moon, is what sets the stage for an eclipse to occur. Next, we delved into the science behind solar eclipses. We discovered that a solar eclipse occurs when the moon, in its orbit around the Earth, comes between the sun and the Earth. This blocks the sun's light and casts a shadow on certain areas of the Earth. The breathtaking sight of the sun's corona peeping from behind the moon is a spectacle that can leave us spellbound. Then we embarked on an exploration of lunar eclipses. We learned that a lunar eclipse happens when the Earth comes between the sun and the moon, causing the Earth's shadow to fall on the moon. This can give the moon a reddish hue, often referred to as a blood moon. The different stages of a lunar eclipse, from the penumbral to the total phase, are a testament to the precise workings of our universe. But appreciating the beauty of these celestial phenomena isn't enough. We also need to observe them safely. We highlighted the importance of using specially designed eclipse glasses or indirect viewing methods to safely observe a solar eclipse. It's crucial to remember that looking directly at the sun, even during an eclipse, can cause serious eye damage. In essence, eclipses are a reminder of our place in the grand scheme of the universe. They're a spectacle of shadows and light, a marvel of celestial mechanics, and a testament to the intricate dance of celestial bodies. They serve as a humbling reminder of the cosmic forces at play far beyond our everyday lives. So, as we conclude, remember that each eclipse is a unique event, a precious moment in the cosmic ballet. It's a reminder that we are part of something much larger, connected to the universe in ways we may not always see. Eclipses are not just celestial events, they're opportunities to pause, look up, and appreciate the grandeur of the universe we inhabit. Next time you witness an eclipse, you'll not only appreciate its beauty, but also understand the celestial mechanics behind it. Keep looking up!